Good morning, students. Today we are going to discuss about ionic bonding. Last day we were discussing about the chemical properties of metals, right? So today we are going to discuss about how metal and non-metal react and what is ionic bonding. Okay. So first let us see, why do metals and non-metals react? What is the reason to react? Okay. Metals and non-metals are usually reacting. There is a reason behind that. So all metal, whether it is metal or non-metal, all the elements are reacting in order to get stability. Okay. So when they will get stability, they will get stability by acquiring full outer shell configuration or octet. Now let us see what is that. Okay. So that is full outer shell configuration, means that is the electronic configuration of noble gases. So look here. Here we can see noble gases. Which are the noble gases? Helium, neon, and argon is given here. So look at the electronic configuration of helium-2. So K shell, we know that K shell, the maximum electron we can occupy is 2. So that K shell is complete here. So it is a stable gas. Okay, so that is why it is called a noble gas. It is not going to react with any other atoms because it is already stable, because it is having full outer shell. Now look at neon. Neon is having 2,8. The second shell, okay, this is its outermost shell, right? That contain 8 electron. That means the last shell is completely filled. Okay, since it is completely filled, it is stable, no need for any sort of reaction, right? So in the case of argon also 288. Okay, so the last shell contain 8 electron, right? So it is also stable. So only in the case of helium, we can see 2 electron because it is having only one shell. All the other cases, we can see the outer shell contain 8 electron. That is the complete outer shell. Okay, that is the noble gas configuration. But in the case of helium, it is 2. Okay, so if these elements are having, or the atoms are having the noble gas configuration, then they will be stable. But all the elements are not having, all the atoms are not having noble gas configuration. Okay. Since they don't have noble gas configuration, they will try to acquire noble gas configuration. Okay. By reacting with the other atoms. Okay. That is the need for a reaction. Okay. So all the atoms are not stable. They don't have full outer shell electronic configuration. So in order to get octet, octet means 8 electron in the outer shell, they will react with some other atoms, okay, and they will get stability. Understand? So we can see metals. These metals, if you see sodium, magnesium, aluminum, potassium, and calcium, how many electron in the outer shell? 1, 2, 3, right? And here also 1, 2. So the number of outermost electron is very less, right? The number of outermost electron is very less. Only 1 for sodium, only 2 for magnesium, and only 3 for aluminum, and for potassium and calcium 1, 2 only. So what these metals will do is they will lose electron during bond formation. Understand? During the reaction, they will lose electron, because if they lose this 1 electron, it will get noble gas configuration of neon, right? Sodium will get the noble gas configuration of neon. Okay, so if this magnesium, if it leave these 2 electron, it will get the noble gas configuration again of neon. Understand? So leaving this electron, 1 or 2 electron, is better than adding how many electron? Here you have to add 7 electron. That's very difficult. So the leaving 1 electron is better than receiving 7 electrons. So metal always, what will happen to metal? Metal will leave electron. So whenever metal leave electron, it will get a positive charge. So metal will be always positive. Okay. Now let us see the case of non-metal. In the case of non-metal, See how many outer shell electrons are there. They have more number of outer electrons, right? So for nitrogen, it only needs three electron, and here two, here one, like that. So in the case of non-metal, addition or receiving electrons are better than leaving these more number of electrons, 5 electrons, right? So always non-metal will receive electron, like nitrogen will receive 3 and oxygen will receive 2, like that. It will receive electron. So whenever an atom is receiving electron, it will get a negative charge. So non-metal will be always negative. Okay, electronegative. Now let us see what is the definition of ionic bonding. So I already discussed that the metal will be leaving electron and forming positive charge, and non-metal will be gaining electron and getting negative charge. So you are getting positively and negatively charged ions. Okay, so when once you get positively and negatively charged ions, there will be attraction between this oppositively charged ion. That is called ionic bonding. So what is ionic bonding? Electrostatic force of attraction. That is attraction between oppositively charged ion. Okay, between positively and negatively charged ion, which are formed by giving and taking of electron. Okay, by positively charged ions are getting by leaving electron, and by taking electron we will get negatively charged ion. Okay, so next we can see what are the conditions. Actually, the ionic bond will be forming between metal and non-metal. Usually, exceptional cases are there. Usually, it will be forming between metal and non-metals. So metal always lose electron and form positively charged ion. Already we discussed this. Okay, metal has a they have only few number of electron in the outer shell. So they will leave that electron and they will form positively charged ion. Okay, so they will be always electropositive. But non-metal always accept electrons. Okay, so they will be electronegative. They will be negatively charged. This is the things we have to remember before understanding ionic bonding. Now let us see one example of ionic bonding. Look at this diagram. In this diagram, we already know that what is sodium. Sodium atomic number is equal to 11, and for chlorine atomic number is 17. So if you write the electronic configuration, this is 2, 8, 1, and for here it is 2, 8, 7. Okay, so 2, 8, 1 is there, 2, 8, 7 is there. Okay, so here we know that leaving this one electron is better, and for the case of chlorine, we know that gaining one electron is better. So what actually is doing? Outer shell of sodium contain one electron, that will be completely transferring to chlorine. Okay, so this one electron will be completely transferring to chlorine. So that what will happen? It will, sodium will get the noble gas configuration 2,8, and at the same time this chlorine also will be getting the noble gas configuration 2,8,8. Understand? And one change happened here, because it is leaving electron, it will get a positive charge. Because chlorine is gaining electron, it will get a negative charge. How many electron it leaves? It leaves only one electron, so one positive charge. Okay, it gains one electron, so it will get -1 charge. Okay, so now positively and negatively charged ions are here. This red indicate the electron from sodium. Okay, so there will be an attraction between them. That attraction is called what? Ionic bond. Okay. Now let us see the case, another example. Another example, let us see. Okay. This already, again, it is explaining about sodium. Sodium is leaving one electron, so it becomes Na plus 2,8. We discussed already. Cl is getting electron and it becomes Cl minus, and the configuration 2,8,8. Okay, this is what this figure is explaining. And now, if sodium and chlorine were to react, the electron lost by sodium, okay, could be taken up by chlorine. Okay, we already have seen that. After gaining an electron, the chlorine atom get a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L, and M shells. This gives us a chloride anion, that is L minus 1 it is, Cl minus 1, okay. Now let us see another example of magnesium oxide. So if you take magnesium oxide, magnesium, what is the atomic number? 12. Oxygen is 8. So if you write the electronic configuration, 2, 8. If you write the electronic configuration for oxygen, it is 2, 6. So it need 2 electron and it has 2 extra electrons. So this two extra electron will give to this. Since magnesium is leaving 2 electron, it become Mg2 plus, since it is leaving 2 electron, okay. Since oxygen is gaining 2 electron, it become O2 minus, okay. This magnesium 12 indicate what? It has 12 electron, 12 proton, right? Number of electron is equal to number of proton, okay. So proton is having positive charge, electron is having negative charge. Now you are going to leave, so overall charge here should be 0, right? Plus minus 12 and plus 12. So overall charge will be 0 here. Now, if you leave 2 electron, what will happen? It become 10 electrons and 12 protons. So plus negative. When you add up this, it become 2 plus, right? That is why it is getting a 2 plus charge. Same thing we can see in the case of oxygen. Oxygen is having 8 electron and 8 proton. So overall charge will be 0 if you are taking oxygen atom. But when it receives 2 more electron, what will happen? 8 plus 2, 10 electron will be there and 10 proton will be there. Sorry, 8 proton will be there. So this is minus, this is plus. When you add them together, you'll get minus 2 charge. This is the reason why you are getting charge like this, okay? So here you can see the 2 electron present in outermost shell of magnesium is going to oxygen. So that oxygen is getting 8 electron in the outer shell. At the same time, magnesium is getting 8 electron in the outer shell. And they will get 2 plus and 2 minus charge and they will attract and form ionic bond. Okay. Now, let us see one more example. In the case of magnesium chloride, how the reaction will take place. If you see the case of magnesium chloride, you can see magnesium contain 2 electron in the outer shell and chlorine. Magnesium, we already discussed the magnesium is 12, so 282, right? And for chlorine, how it will be? Chlorine 17, so it is 287. So it has 2 electron and chlorine wants only 1 electron, right? So if you give 1 electron to this chlorine, 1 extra electron should be there. So what we need to do? Take 1 more chlorine and give the extra electron in it to that chlorine. So what we are going to do? Magnesium has 2 extra electrons. So 1 chlorine is not enough. We will take another chlorine and give the extra electron to this. And since magnesium is leaving 2 electron, it becomes Mg2 plus. Since each chlorine is getting 1 electron, each chlorine is having minus 1 charge. Okay. 2 Cl minus 1 we will be getting. Okay, this is the case of ionic bonding in magnesium chloride. Now, another is lithium oxide. Okay, in lithium oxide, how the reaction will be taking place? Look at lithium. Lithium is 2-1 electronic configuration and oxygen 2-6 and again lithium 2-1. So it has 1 extra electron. Each lithium has 1 extra electron. So each lithium will give electron to oxygen so that it will get 8 electron in the outer shell. And each lithium, since it is giving only 1 electron, plus 1, plus 1. Don't add and write plus 2. That is wrong. So lithium plus 1 and another lithium plus 1. And since the oxygen atom is getting 2 electron, it becomes minus 2. Okay, so this is the formula. To always write the metal first. So 2 lithium we are using. So Li2O1 oxygen. Okay. Now, aluminium oxide. Look at aluminium oxide, how this will form ionic bond. Okay, so in this case, look at this aluminium. This aluminium is having, aluminium is 13, so the electronic configuration is 283. And for oxygen, it is 8, so 26. Okay. So this aluminium is only at first only taking 1 oxygen and it is giving 2 electron to oxygen. So it will get noble gas configuration. But what is the problem? 1 more electron is there. So aluminium has to leave that electron. So in order to leave that electron, it will take one more oxygen. So it will give only, it can give only one electron, right? But oxygen actually need two electrons. So what we will do, again take one more aluminium. That one electron give to this oxygen, okay? So again, it is not enough. See, two electron in the new aluminium is there. So that we have to give to oxygen. So again, we will take another oxygen and we will donate this two electron to oxygen. Now it is tally, okay? So all the oxygen is getting two electron and aluminium is removing all the 6 electron. Understand? Since each aluminium is removing 3 electron, it is getting 3 plus charge, and oxygen is getting, each oxygen is getting how many electron? 2 electron. So all we get 2 minus charge. So how we will write the formula? 2 aluminium we used to first write metal, 2 aluminium we used, and oxygen, how many are there? 3. So Al2O3 is the formula, right? Now let us move to the properties of ionic bond, ionic compounds. So what is ionic compound? The compound which containing ionic bond is called ionic compound, okay? So their properties are, they are usually hard, high melting and boiling point they have. They are brittle, they will not conduct electricity in solid state, and they conduct electricity in liquid and aqueous state, and they are soluble in water. Now let us see each properties, okay? Why they are hard, okay? What is the reason why they are hard? So the answer for that is, they have high electrostatic force of attraction between ions, okay? They have ions, right? So they are oppositively charged. So the force of attraction between these ions are very high. So we need high energy to separate this ion. That is why they are very hard and they have high melting and boiling point. Very important question. So why not conduct in solid state? They are not going to conduct electricity in solid state. What is the reason? Because in solid states, the ions are closely packed. Okay, they are very closely packed in solid state. So they cannot, the ions are not free. That is the reason why they are not conducting electricity in solid state. But they will conduct electricity in molten or aqueous state. So we know that whenever this ionic solids, whenever they are dissolving in water, what will happen? They will separate into Na plus and Cl. If sodium chloride is put in water, Na plus and Cl minus ion, they will separate there. Okay, since they are separating, they will be free. Okay, so what do you mean by molten? When you take NaCl and only NaCl, okay, NaCl you take and heat it, so NaCl will convert into a liquid state. So there we can see Na plus and Cl minus ion only, and they will be free also. Freely they will move because it is liquid state, so they can conduct electricity. Okay, so next is here in this case Na plus and Cl minus, that is aqueous state. Aqueous state means water. Inside the water, if you are adding NaCl, that is called a aqueous solution of NaCl. This is molten. If you heat it and convert into a liquid, then it is molten. Aqueous state means NaCl, when you are putting in water, that is aqueous solution of NaCl. There also it will split up into Na plus and Cl minus ion. Being in solution, they will be free, the ions will be free, and they can conduct electricity. Okay. So next is solubility in water. They are soluble in water and insoluble in petrol. Soluble in water. So what is the reason? When they put in water, already we discussed, they will be separating into ion and they will dissolve. That is the reason. Okay. But they cannot separate into ion in the case of petrol. Petrol molecule, they don't have the capacity to separate the ions. Okay. Now let us see what is corrosion. Corrosion means, corrosion is a natural process which convert a refined metal, that's a pure metal, will react with whatever is present in its surrounding, like oxygen, water, and it will convert into its corresponding oxide, hydroxide. Okay, so gradually the refined metal will undergo destruction. That is called what? Corrosion. Okay, Now let us look at silver. Look at silver. This is a silver statue. And what is happening to this? It become black color. What is the reason why silver is black color? Gradually it is become black color. What is the reason for that? Because any silver article that will undergo reaction with the sulfur when exposed to air. Understand? Not only oxygen, it is reacting with the sulfur. When silver react with the sulfur, it will form silver sulfide. It is having a black color that will deposit over that article. That is the reason. Okay. And next is, why does look at this copper rod? This copper rod, when you expose to air, it becomes green. What is the reason for that? Because this copper will react with carbon dioxide. Understand? So when it reacts with the carbon dioxide, it will form copper carbonate, which is having a green color. That is the reason. Okay. So now let us see what is rusting. Rusting is a special case of corrosion. When the corrosion is happening in the case of iron, then it is called iron, then it is called rusting. Okay, rusting when exposed. So we need some condition for rusting to take place. Okay, so what are the conditions for rusting to take place? There must be water and there must be air. Water we will get from moisture, and oxygen we will get from air. So these two conditions are there, then only rusting will take place. Okay. Now, let us see this experiment. Some students are doing this particular experiment. Here, in one test tube, we are only taking water and we are keeping a nail over there. And another test tube we have taken, then boiled water we have taken, and we put 2-3 drops of oil over it. And another test tube we have taken, inside that we put calcium chloride, and we close all that, and we kept it for 2 to 3 weeks. So what happened? We have noticed that only rusting take place in water here only. Okay. So what is the reason for that? Because we know that two conditions are necessary for rusting. So here the nail is having water, and at the same time above air is there. So since water and air is present, it will undergo rusting. Okay. What is the color of rust? Color of rust is brown. We are seeing everyday life, right? Rust. And if you see the boiled water means all the dissolved oxygen will be eliminated by boiling water. Okay. And if you put an oil, there should not be any contact between the nail and the air. So what will happen? The nail is not going to get air or oxygen, so rusting will not take place there. Okay. Only water is available. In this case, we put calcium chloride. Calcium chloride is called a drying agent. So what this calcium chloride will do, the air is already present, but all the moisture it will attract, it will absorb on it. So that what will happen, it will not undergo rusting because air is not, oxygen is not available. Sorry, moisture is not available. Dry air is there, so moisture is not available because calcium chloride absorb all the moisture present in the air. That is why it is written dry air. All the moisture who will absorb calcium chloride will absorb. Okay. Now, what are the different methods to prevent corrosion? You can paint the iron article, or oiling, greasing, galvanizing, chrome plating, anodizing, alloying. All these are different methods to prevent rusting. What do you mean by alloying? Or what do you mean by galvanizing? Galvanizing means the iron article will be coated with the zinc. So what will happen? Only zinc will react there. Okay. Zinc is more reactive than iron, so zinc will not zinc will react, iron will not react. Even small scratches are there on that also. What will happen? Zinc is only going to react, iron won't react because zinc is more reactive than iron. So zinc will react and iron won't react, and iron will not undergo rusting. Okay. And next, alloying. What do you mean by alloying? Converting into an alloy is called alloying. Alloy, let us see what is an alloy. An alloy is, it is a mixture actually, and that is homogeneous mixture. Okay, it's a homogeneous, the composition throughout should be same. It's a homogeneous mixture of two or more metal or non-metals. Okay, two or more metals or non-metal. So how we will, to make an alloy, we have to melt the metal and we will mix the other component, whether it is metal, or whether it is a non-metal, we will add non-metal, and we will cool that substance to room temperature, then we will get a alloy. Okay. Now, what is the advantages of alloying? Why we are doing this alloying? We can prevent corrosion, already we discussed. And not only that, the metal get better properties. Okay, the metal is going to get better properties. So that is why we are doing alloying. Okay. So example for alloying, stainless steel. It's a mixture of iron, nickel, and chromium. And it's harder than pure iron and it does not rust. Okay, that is the important property it is gaining. And brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Okay, solder is another alloy of lead and tin. It is using in a welding. So brass and bronze we are using to make vessels, different utensils. Okay. Now, some disadvantages are there. So it will decrease if you do alloying. Its electrical conductivity is less than the pure metal. If you see the case of bronze and brass, copper is present. So the copper is it is a good conductor actually. So, but that conductivity will decrease if you convert copper into brass and bronze. Okay. And melting point of alloy will be less than the pure metal. That is another thing. And now next is, what do you mean by amalgam? Amalgam means alloy of mercury. Alloy of mercury is having a name called amalgam. Okay. That's all for today. Now let us discuss next class about, we are going to discuss in the next class, the next chapter. This is the end of the chapter. Okay.